right? So this is a question on area under the curves, and the question is, find the area that the line y1, which is given by 2x plus 3, cuts off from the parabola y2, which is equal to x squared. So these are the two curves that we're given, and we have to find out uh, the area that this line y1 equal to 2x plus 3 cuts off from y2 equal to x squared. So how do we go about thinking about the problem? Well, it always helps to draw the two curves first, and that way we have a picture of what the curves look like and where they intersect, and therefore what the area that we're looking for might look like. So let me draw a curve real quick, right? So let's suppose this is my y-axis and this is my x-axis. So this is x and this is y. And let me draw the parabola first, right? So y2 equal to x squared, let me draw that first, and let me draw it in blue. So the parabola will look something like this. I'm going to draw this freehand, so please bear with me. So the curve is going to look like this. It's going to graze the origin and it's going to go back up. So how do I know it looks like this? Well, notice for every value of x, either positive or negative, y2 will have to be positive because, well, you're taking the square of that number. And so I know that this curve lies entirely in the positive y region, right? And also, it's totally symmetrical because y2 for plus x is going to be the same as for minus x. So if, which means that the value of this function for plus 3 will be the same as the value for minus 3. So I know that it's symmetrical about the y-axis. So it's a symmetrical figure that is 0 over here and is always positive. So that's how I know that the parabola is going to look something like this. So this is y2 equal to x squared. Now what about the straight line, which I will draw in white? So what about this line over here? Well, notice one thing. It's got a slope of 2. So what does that mean? Well, that means that the line slopes up like this. So this is a line with a positive slope, right? A line with a negative slope would be like this. This is a line with a positive slope. So we know that it's some line that goes up like this. Moreover, if I put x equal to 0 in this equation, then y1 turns out to be equal to 3. So I know that it cuts the y-axis at some point along over here in this region, right? So in this area it cuts it off somewhere. So let me draw a line which satisfies both of those conditions, which means it's sloping upwards and it cuts the y-axis in the positive y region. So y is equal to 2x plus 3 would probably look something like this. Now the area we're looking for is the area that this line cuts off from the parabola, and so that would be this shaded portion over here. So this is the area that we have to find out, and let's call the required area R, right? And one other thing, we notice that the line cuts the parabola at 2 points. Let's call those 2 points M and N. So that's what we have. So this is what it looks like. So the area that we are looking for is contained between M and N. And so if we were to find its area, then how would we do that? Well, if we were to find out the area which is below the line, so the area under the line between M and N, which is this whole area, so if I were to, which is all the area under M, N, X, Y, so this is all the area under the line minus the area under the parabola, which is going to include this little portion over here and this portion over here, then we would get the required area. So basically, if I were to write the maths for it, then R would be equal to, if I were to go from M to N, the area under the line, which is y1 dx, minus the area under the parabola, which is M to N y2 dx. So generally speaking, this is what the required area is going to look like. Now obviously, We don't know what m and n are, so that's going to be our next step. We'll find out what m and n are. So let's go ahead and do that now. So uh, the points where the two curves intersect, there y1 is going to be equal to y2, which implies that 2x plus 3 is going to be equal to x squared there, which in turn implies that x squared minus 2x minus 3 is going to be equal to 0. So now what we have here is a quadratic equation, and we need to find the x that's satisfied. Now that's simple enough. And we know what the roots are going to be like. So x is simply going to be equal to minus b plus minus under root b square minus 4ac divided by 2a. Now now b is minus 2, so minus of minus 2 is plus 2, so that's going to be plus 2 plus minus root b square, which is minus 2 squared, which is 4, minus 4 times a is 1 and c is minus 3. So minus 4 times 1 times minus 3 divided by 2 times 1, which is 2. Right? So I'm actually not going to spend too much time doing this, because this is stuff that you already know. So this is going to be boiled down to 2 plus minus under root 16 by 2, which is 2 plus 4 divided by 2, or 2 minus 4 divided by 2, which implies that x is equal to minus 1 and 3. Right? So these are the two values for x. So there are 2 points of intersection, and we've got the values of x for both of them. So m is going to be equal to minus 1 comma something, and n is going to be equal to 3 comma something. Right? Now I haven't found out what these somethings are, because it really would not be needed, because I will be integrating with respect to x, which means I'll be we'd be running along the x-axis, so I only need the x values. But you can go ahead and find the y coordinates also, just for your curiosity. But it's really not going to be needed, so I'm just going to stick with these x values. So what does this make, given these two values for x? What does that make our expression for r equal to? So r is now going to be equal to minus 1 to 3 2x plus 3 dx minus minus 1 to 3 x square dx, right? So it's as simple as that, which we can rewrite as 2 times minus 1 to 3 x dx plus 3 times minus 1 to 3 dx. So I've just taken the integral inside this expression. So these two terms come from the 2x plus 3 minus integral minus 1 to 3 x squared dx. So let me just scroll down again. So what do we have here? Well, what is integral x to the power n dx? Well, this is simply equal to x to the power n plus 1 divided by n plus 1, right? So here n is equal to 1, so this becomes 2 times x squared by 2 from minus 1 to 3 plus 3 times x from minus 1 to 3 minus x cubed by 3 from minus 1 to 3. So this is the required area, and from now on it's just going to be simple calculation. So I'll just cancel the 2 because that's common, and so this becomes x squared. So the 3 squared is 9 minus 1 squared is 1, so 9 minus 1 plus 3 times x is 3 minus 1 minus sorry about that, x cubed. So 3 cubed is 27, so 27 by 3 is, well, I'll just write 27 by 3 as it is, minus minus 1 cube is minus 1, so minus 1 by 3, right? All that I've done is just plugged in the values, and therefore this gives me 8 plus 3 times 3 minus minus 1 is 4, so 3 times 4, which is 12, so I'll just write 12, minus 9 plus 1 by 3. So this turns out to be 20 minus 9 minus 1 by 3, which is 11 minus 1 by 3, which is 33 minus 1 by 3, which is 32 by 3, which you can also write as 10 2 by 3, right? So this is the value of R that we're looking for. So this shaded portion over here has an area equal to 10 2 by 3 square units. So so that was a question, and that's how it's done.